Welcome back to our series on Learjet systems and maintenance. In this video, we're moving to the tail section to explore the flight controls that provide stability and directional control, the elevator, rudder, and the vertical stabilizer. Together, these components ensure the aircraft's pitch and yaw are precisely controlled.
First, let's identify the elevator. This is the movable control surface located at the rear of the horizontal stabilizer, which is the small, wing-like structure on the tail. The horizontal stabilizer provides stability along the aircraft's pitch axis. The elevator itself is responsible for controlling the aircraft's up and down motion of the nose. Next, we have the rudder. The rudder is the movable control surface attached to the trailing edge of the vertical stabilizer, the large fin at the top of the tail. The vertical stabilizer provides directional stability, while the rudder's job is to control the aircraft's yaw, which is the left and right movement of the nose.
When a pilot wants to change the aircraft's pitch, they use the control column. Pulling back causes the elevators to move up, creating a downward aerodynamic force on the tail. This pitches the nose up, allowing the aircraft to climb. Pushing forward does the opposite, pitching the nose down for a descent. For yaw control, the pilot uses the rudder pedals. Pushing the left pedal moves the rudder to the left, which pushes the tail to the right and causes the nose to yaw to the left. Pushing the right pedal does the opposite. The rudder is most commonly used in conjunction with ailerons to make a coordinated turn or to correct for a crosswind during landing. These tail flight controls are absolutely vital for maintaining stable and controlled flight. The elevator is the primary control for the aircraft's pitch axis, enabling the pilot to climb, descend, and maintain level flight. The rudder is the primary control for the yaw axis, allowing for controlled, coordinated turns and correcting for crosswinds. Without these two surfaces, the Learjet would be unstable and nearly impossible to control. Now, let's cover the basic maintenance checks for these flight control surfaces, which are performed as part of a routine pre-flight inspection. First, conduct a thorough visual inspection. Look carefully at the entire surface of the elevators and rudder. Check for any physical damage like dents, cracks, or loose rivets. Such damage can affect the aerodynamic performance. Next, manually check for freedom of movement. Gently try to move the surfaces. There should be no excessive looseness or binding. Also, look at the hinges, linkages, and actuators for any signs of hydraulic leaks, corrosion, or loose bolts. Finally, confirm full and correct movement. This is often done from the cockpit by cycling the controls. You would confirm that the elevators and rudder move through their full range of motion smoothly and without binding. Any restricted movement or damage must be reported to a certified mechanic. That concludes our detailed look at the Learjet's elevator, rudder, and vertical stabilizer. Their combined function is what gives the aircraft its stability and precise control. Be sure to scan the QR code for more detailed information. See you next time!